So in this video, we're going to start talking about the mole. And remember, mole was our SI unit for the amount of a substance, right? Mass was the amount of matter that something's composed of. Kilograms was our unit for that, our SI unit. Volume was the amount of space something occupies. That was a derived unit. But the unit for how much stuff we actually have, we're going to measure that in moles. That's going to be our SI unit. So atoms, compounds, molecules, right, they're incredibly small, right? They're on the microscopic level. And we need a way to be able to go into lab and measure things. And we can't measure out the number of atoms and compounds because they're just so tiny. So we need a macroscopic unit. And that's what the mole is representing. So 1 mole is actually a really large amount. But again, it is just our SI unit for amount. So mole. Our abbreviation is MOL. It's not much of an abbreviation, but if you write it a lot, it does save some time. And this was the SI unit for the amount of a substance. So how much do we actually have? And it could apply to anything. How much carbon do we have? How many calculators do we have? Whatever it happens to be, it's our SI unit for amount. And then how many, right, is 1 mole? 1 mole, and most of you should know this number, is Avogadro's number worth, so 6.022 times 10 to the 23rd of whatever that happens to be. So I'm just going to write items. Right? If I had 1 mole of carbon, it would be 6.022 times 10 to the 23rd carbon atoms. If I had a mole of calculators, it would be 6.022 times 10 to the 23rd calculators, right? It's just a number. It tells us how much we have. It could be how many atoms we have, how many compounds we have, how many calculators I have, how many kitty cats I have. It doesn't matter. It's just a number, right? It tells us how much of whatever that item happens to be. It happens to be a huge number, right? 6.022 times 10 to the 23rd. I mean, it's giant, right? It's not, I mean, that many cats would like circumnavigate the world to probably several feet high. Like, it's crazy how many cats that would be. That would be insane. But again, it's just a number representing the amount of our substance. The name of that number, I said it, but I didn't write it down. This is Avogadro's number. Abbreviated a capital N with a capital subscript A. So N sub A is Avogadro's number. So if I said, if we have 1 mole of something, how many do we have? You could say Avogadro's number's worth. I'll probably ask you to, what is that number? 6.022 times 10 to the 23rd. But that is the name of that number. A common analogy is to compare a mole to a dozen, right? If I had a dozen of something, how many would I have? Yeah, 12, right? And it doesn't matter what it is. We could say items. If I had a dozen carbon atoms, I'd have 12 carbon atoms. If I had a dozen calculators, I'd have 12 calculators, right? A dozen cats, I would have 12 cats. So a mole is similar to that in the fact that it's just a number. It's much larger, right? Avogadro's number is a much larger number than 12. So again, the SI unit for the amount of a substance, 1 mole is the equivalent to this. And I do want us to know that is going to be a number that we're going to need. And again, it doesn't matter what it is. A lot of times we get stuck on chemistry because it's chemistry and we think a mole is something that's just magical and only related to this topic. It's not. It's just like a dozen, right? I could have a mole of donuts. It's not practical or probably even possible, but again, it's just how many donuts would you have? You would have Avogadro's numbers worth, right? I would have 6.022 times 10 to the 23rd donuts. So the next thing I want to talk about in this video is molar mass. And molar mass is defined as the mass measured in grams, so that's going to be my units, of 1 mole of a substance. So if I had 1 mole of carbon atoms, what is its mass in grams? If I had 1 mole of calculators, what is its mass in grams, right? We could calculate the molar mass of a calculator because we would take the mass of 1 and we would multiply by Avogadro's number, right? If I have 6.022 times 10 to the 23rd calculators, what is its mass? That's all that molar mass is. So the mass in grams of 1 mole of a substance. And since this is chemistry, we're generally talking about the molar mass of atoms or compounds, but again, it could apply to anything, right? Grams, that's just a unit for mass. It doesn't have to be measuring atoms. I could be measuring horses if I wanted to be, right? And then mole is just a number. So if you had 6.022 times 10 to the 23rd of something, how many grams does it weigh, right? That's our molar mass. So the mass in grams of 1 mole of a substance. We are going to relate it to atoms, of course, because this is chemistry, but numerically, it's the same, and this is for atoms, as the atomic mass. We talked about atomic mass in our last video, but with units of grams per mole, right? Because it's the number of grams per mole, that's my definition, instead of atomic mass units. Again, be careful. Numerically, it's the same. Conceptually, totally different. They are not even remotely the same thing, right? It just happens that the number is the same. So numerically the same, not conceptually, right? Conceptually, atomic mass is the weighted average mass of all of an element's naturally occurring isotopes. Molar mass is the mass in grams of 1 mole of it, right? 1 mole is huge. So we're not just taking percent abundances of isotopes. We're actually saying, okay, if I had 6.022 times 10 to the 23rd of that, what would its mass be? So numerically it's the same, conceptually very different. And then be careful, because this will trip people up every time. And I don't mean to. I'm just trying to test you to see if you actually know the material. And I will give, let's just use carbon, because that's usually my example. If you go to the periodic table and look up its atomic mass, it's 12.01. And then the units are AMU. So that's my atomic mass. The molar mass then, numerically it's the same, so 12.01 grams per mole. So on a multiple choice exam or quiz, I could ask you what is the atomic mass of carbon, and if you picked this answer, you would actually be wrong because the units for atomic mass are atomic mass units, right? If I said what is the molar mass of carbon, then you would want to pick the one I just picked across. Numerically, again, it's the same. Units are different. Conceptually, it's different. So just be careful. I do want you to know the difference. I'm not trying to trick you. I'm trying to see if you actually know the difference. So be careful on that. Know the difference, and then you'll be fine. So molar mass, the mass in grams of 1 mole of a substance, numerically the same as the atomic mass, but with units of 1 gram. Of grams per mole instead of atomic mass units. So essentially, let's use hydrogen just for something different. If I have 1 mole of hydrogen, I have 6.022 times 10 to the 23rd hydrogen atoms, right? That's the number of atoms we have in 1 mole. And then I am going to use my periodic table. I'm going to look at my atomic mass, and I'm going to know that the number there is numerically the same for my molar mass. So I know that this many atoms would weigh 1.01 grams. So 1 mole has a mass of 1.01 grams, and then it contains 6.022 times 10 to the 23rd atoms. Right? 1 mole of carbon, 1 mole is always 6.222 times 10 to the 23rd hydrogen atoms. And then using the periodic table again, looking at my atomic mass, and then knowing that numerically it's the same as my molar mass, it would have a mass of 12.01 grams. And we could just, pick any atom on the periodic table, we could write this. We could actually calculate the molar mass for something completely crazy. Let's do my cat. That's always fun. At least fun for me, maybe not fun for you. So we're going to say, what is the molar mass this always makes me giggle a little bit, of Jen's cat Lizzie. We're going to have to do some unit conversions in this problem too. If she weighs, she's gotten fat lately, 11.8 pounds. She should only weigh 10, but she weighs close to 12. So the easiest way to do this is to keep in mind what molar mass is, right? If we go back up to our definition, it's the mass in grams of 1 mole of a substance. So if I have 6.022 times 10 to the 23rd of Lizzie, how much does it weigh in grams? That's all I'm asking. So we do need to convert from pounds to grams. That is a conversion that we're going to have to do. So this is a good time to show you. I posted on Canvas under the course resources page it's a pretty bad photocopy, sorry, or scan. I'm old, I say photocopy, that's pretty funny. But it's got some useful conversions. So if you're doing practice problems and you need a conversion, this is a great place to go. So I'm just going to steal one from here. So we know that 1 pound is 453.59. So let's see if I forget that by the time we go back. 453.59. So 453.59 grams is equal to 1 pound. So I'm just going to do a unit conversion real quick, converting Lizzie's mass to grams. Remember, molar mass is in grams, so that's why we need to do that. So this is how many pounds per cat, right? That would be my units. And you could leave Lizzie off there. I'm just putting it there for when we convert to the number of moles. So 11.8 pounds per cat. I know that there's 1 pound. Pounds are on top, so they have to go on the bottom for 453.59 grams. And we could do this in one step or two. I'm doing it in two, but we could totally do it in one. My pounds cancel. So this is how many grams per cat we have. So 11.8 multiplied by 453.59. I get 5,352, but I do only want 3 significant digits, so I'm going to round that to 50. And that's how many grams we have per Lizzie, okay, per cat. We want to know how many pounds we have if I had a mole of them, right? This is if I have 1 Lizzie, right? And I want the mass of a mole. So I'm just going to then take this number and multiply by Avogadro's number. And we could set that up dimensional analysis too if we wanted. So grams per cat, right? And I know that there is 6.022 times 10 to the 23rd items, in this case cats, or Lizzie, I switched it on you, per mole, right? That's what that number tells me. If we go back up, right here, it's just an equality. So I'm just using it for dimensional analysis. 1 mole is that many items. The item in this case is a cat. So my units are going to cancel. And we're going to be left with my molar mass. And it's going to be a big number. As 6.022 times 10 to the 23rd cat should be, right? What does that weigh? A lot. So I get 3.22 times 10 to the 27th grams per mole. So that would be the molar mass of Lizzie. Right? What is the mass? 1 mole of her. So molar mass for compounds, something we're going to be using a little bit more, though the concept we'll be using all the time. So if the molar mass for an atom is numerically the same as the atomic mass, we just switch our units. For a compound, we then just add the atomic masses, right? The number for our atomic masses for all of the atoms in a compound. So essentially, it's just the sum of all the molar masses for all of the atoms in the compound. So the sum of all the molar masses. I should probably try a little bit harder for my handwriting, guys. Sorry. Sum of all the molar masses for all of the atoms in the compound. So kind of a quick review. I don't think we reviewed this yet this semester, but when we write the chemical formulas for our compounds, we always give the atomic symbol for the atoms and then a subscript after that symbol telling us how many of that type of atoms we have. So water, capital H for hydrogen, a subscript 2 that tells me I have 2 hydrogen atoms, and then O for oxygen. And then if there isn't a number there, it's just 1, so 1 oxygen atom. So in a compound of water, I have 1 oxygen atom chemically bonded, remember compounds have chemical bonds between them, to 2 hydrogen atoms. And if I wanted to calculate the molar mass for this, I'm going to get the atomic mass for hydrogen off of the periodic table, switch my units, so 1.01, and then instead of atomic mass units, grams per mole. In water, I happen to have 2 hydrogen atoms, so I'm going to multiply that by 2. Oxygen, again, off the periodic table, I'm going to round it. Most atomic and molar masses, I'm going to round to 2 digits after the decimal point, which I'm totally cool with you guys doing. Just don't round to less than that. If you want to carry out more than 2 digits after the decimal point, that's fine, but not less. So don't, for hydrogen, don't say 1.01. So 16.00, there's 1 of them. And then it says the sum. So we're literally just going to add those together. So my molar mass for water is 18.02 grams per mole. Right, so again, what does that number mean? It means that if I had 1 mole of water, I would have 6.022 times 10 to the 23rd molecules, or compounds, you could write compounds, and it would have a mass of 18.02 grams, right? That's what that number means for us. So 1 mole gives me this many molecules or compounds, and then 18.02. If you don't remember from your chemistry past, a molecule is a compound with covalent bonds between them. So we could call water a molecule. If you don't remember covalent bonds, don't worry, we're going to review that. But water could be called a compound or a molecule. Let's do something that has some more atoms in it. Actually, let's do something with parentheses. So calcium hydroxide, just to review notation for compounds. So again, remembering from your chemistry past, if you have parentheses around an atom or a couple atoms, and then a subscript outside of those parentheses, then everything within those parentheses gets multiplied by that number. So again, just looking at our periodic table, calcium is 40.08. Again, I generally round to 2 digits after the decimal point. You can carry out more, just not less. There's only 1 of them. I changed my units from atomic mass units. Oxygen, there's actually 2 of them, right? There's a hydroxide ion, and then there's 2 of those. So 2 oxygen, and I'm just going to multiply by 2 right away. So 32.00 grams per mole. And then hydrogen, Again, there's 2 of them because it's also inside the parentheses. Multiply by 1.01 gives me 2.02 grams per mole. And then when we add that all together, I'm grabbing my calculator here, though we probably for sure should be able to do this without a calculator. I get 74.10 grams per mole. Do be careful, this is actually a really good point. If you grabbed your calculator and did this with me, which I always would highly recommend doing, I actually get 74.1 as the answer in my calculator. But remember, calculators don't know significant digits, and I'm adding here. And remember, our rule for adding is number of digits after the decimal point. So here I have 2, here I have 2, here I have 2, so I need 2. So this only gives me 1, so when I wrote down my answer, I had to add that additional 0 to it. So be careful. Your calculator is going to give you the magnitude, but remember there's 3 parts. I had to know to add the 0, and I needed to add the grams per mole also. So molar mass of compounds, you just take the atomic mass right from the periodic table, change your units to grams per mole, and then take into account how many of each type of atom we have and sum them together.